So next concept to be tackled is how do we retrieve the information that we wanted. So let's say that we have a list of columns, we have a list of lines, and we have a list of elements that are belonging to a particular type that we want to have them. So let's say we want to know which ones are on level 2. That's a specific parameter we can graph. So for pulling a property from an element, in that case structure on Revit Dynamo goes by reading an element. The element should have all properties from element, and we have one node that it's called get parameter value by name. So rather we can call them, and that's going to be the element, and the parameter name we want to have, it's going to be called the level. So structure goes pretty simple when we're reading all the levels of the element. The only thing here is that we want to filter out which ones are working. Our best way to do it is first we need to change this one, because as we can see the green number popping, it means that this is an element. So this element needs to be decomposed in something that is basic, such as a string, a double, or an integer. Otherwise we cannot compare it because there are class elements. So we can look for the properties on a level. Let's say we go for a level, and level we can call them by name. If we do it so, we will have something like this, that it's having level 1 and level 2. And from there we can call it, so we can use an if statement. So this is pretty basic. We can use the bool mask, filter by bool mask, as a selector, or all indices of as another type of selector. Difference will go that the filter by bool mask will separate conditionals to be true or false, and list index by all index of will give me just the ones I'm looking at. So let's do both. First of all, we need to have the one we're looking for level 2, being called as the item, reading from the string, will give me these numbers. And since we already have used the get item at index, we can call the indexes from the elements. Just remember that it's having the same number, having 12 elements, 12 elements, 12 elements. I'm picking just 6, and the 6 that I want are the ones that are the final list. Or we can also do it with an equals. In this case we can see one that it's tolerance and ones that it's not tolerance. The ones that is not tolerance is actually using string values, so it's going to be better for our relation to work. If they are compared, they give me the result as true. That's going to be our mask, our elements, and now we have the in and out values. We can compare that those two are the same, whereas the in is being filled out. 6, 8, 10, 12, 14, and 16, and so on. We can work with those so that they are retrieving the information we are requiring. The same thing can happen with any other type of structure, using it as a line pattern element. We can call for any other parameter. Just going to copy this one. I think from line pattern elements we need to look for a property that they might hold. They have just get by name, line parameters. So if there's a get by name, we can also select a name parameter from the element. That's bringing the naming convention. And mostly things that go with a list can also go within a string. So instead of using the index of, we can use a contains contains as a string. So we can have all the dash elements. We have 4 values that are working with that one. We can use the filter by bool mask, or we can also use the all indices of, but calling it with a true value, so we can have just the true value element, and then pulling it up with a getItem@index. That will bring the line pattern elements of the ones that have a dash definition on their name. So let's continue doing this one. Next, we're going to start working with Python, so we can have this one much more faster, and then we can jump into the interfaces.